Hello 108 students, Mr. McHugh here with you, getting ready to kick off section 10.6, our last section of chapter 10 and our last section of 108. So hey, we are almost there, class. We've been doing great here, so hang in there with me. Got about 6 more videos to do, 6 more pages of class notes, and we will be done. So let's kick off this section here, exponents and logs. Exponents and log equations with applications. Here we're going to focus on, we're going to be on page 615, and they've got a blue box in there, and they've got properties for solving equations when look at the variable is up in the exponent. That's where they want you to see here. So a couple things, they kind of make sense here if you look at them, but it says rule A is exponential equations. If you have the same base on the left side and the right side of the equation, then you can set the exponents equal. And that's what this is trying to say. Now, you look at these rules, again, try to say them in English, rewrite them in English so they make sense to you, okay? Mathematicians use the lawyer, I call it the lawyerese writing, to write down what properties they found, but translate them so your brain will remember the words for you. Okay, and thus you can see my interpretation of that. And again, when you take that and write this down into your own hand notes, then it helps drill it in your head so you remember them. Plus, you'll be able to use them for 143. Okay, now I combined in the book my rule letter B is a combination of rules 3 and 4 in the book, and that's because it goes both ways. And I guess what I'm trying to say here is, if you look at this, if you have a log with a base with a result x, and on one side and you've got the same log on the right side with the same base, then the results are equal. Okay, that's what that's trying to tell you. And also you got to make sure they both are greater than 0. Okay, so we got some of these guidelines here for us. Methods for solving these here. This is my guidelines here for you. General methods, first one, take the logarithm to the same base on both sides. So just like maintaining balance, you can take the log on both sides of the equation and then use the power rule of logs or special properties that log base with the result b of x kicks out the exponent. Okay, so you see this. If this doesn't make any sense to you, go back and study in our previous sections what this is all about, so you can help drill it in your head. Use examples so you get it. Roman numeral 2. Oh, I'm having a good time talking here today. Special case of both sides as bases, then the same equation, then set the exponents equal, rule A. Okay, so that's just to review what we got here. Now let's get down here and do a problem. So what's funny is, if you look at this problem, we started this out way back like at 10.1 how to do this. Now that we understand logs, the way to approach this now, I'll say a quicker way, is to realize the variable is up in the exponent. Let that kick off in your brain. Take the log on both sides. Okay, let that be your driver. And you maintained balance on the equation. And so if you take the log on both sides of the equation, that kicks the log of 3x, 3 raised to the x equals log of 12. Now, here's the key. From here, that exponent kicks out, comes down by the power rule, and now you've got x there on the line. It's taken out of the exponent. That's the beauty of it. Now you've got times log of 3 equals log of 12. Okay, now look at that step and focus on that. Focus on this line first. I was running out of space a little bit. Then what I did was I isolated the x term by dividing by log of 3 on both sides of the equation. Okay, hopefully you're hearing that. Then you've got to remember, now that, of course, anything divided by itself equals 1, so 1 times x is x. That's cool. Then you got to remember this. You got to make sure you don't forget here, because we're trained with the division. Log of 12 divided by the log of 3 does not equal the log of 4. You have to separate the log of 12 in your calculator, 1.08. The log of 3 turns out to be 0.477. Divide them out in your calculator, kicks out your final answer, 2.262, which is an approximate. If they ever ask for exact solutions, which I think most of the problems are approximate, but then you would leave it like this with the word log in there. Now, Up here, I'd like to write an alternate solution to this problem for you. And what I'm going to propose here now is, this is interesting, 3x equals 12. And what if somebody said, you know, can I convert this into logs? So, yeah, let's think about that. What would you do? You would write log. Okay, now here we go. Again, every time I say this, I love log of what? What's the base? 3. What's the result? 12. Has to equal what? The exponent? Okay. Now, what's interesting about that, as soon as you do that, class, look what you got here now. What? Hopefully from our last section, what's kicking in your brain? We learned to do the what? Change of base rule. So I'll write it here. Change of base rule. Okay. Now you could turn around and say log of what? Log of the result divided by the log of the base equals x. And does that match what we have down here? Bingo. Follow these steps over here, aka plug them in your calculator, and you got it. Okay, Mr. McHugh, we have kicked off page 1. Now again, I've said this before, but what am I telling you about example number 1? You're going to see this on the quiz. Okay, so I try to take these examples and streamline everything so you guys know exactly what you need to focus on to get you through this remaining chapter, and how fast we got to cover everything here in the last week or so of school. Okay, of this semester. Okay, class, so take care, and I will see you for page 2. Okay, bye.